Hi, welcome to the brain. Yes, your brain. Not really your brain, but anyway, the brain, which you need to know about. And here is an awesome website for you to find out about it. Check it out. You can read that, so I'm not going to tell you. But visit that and you get this guy that gives you all of the parts of your brain. Frontal lobe, parietal lobe, occipital lobe, temporal lobe. All nice colours, all nice little labels as you hover over them. Cerebellum and brainstem. You'll learn a little bit more about those later. But remember our acronym. FPOT. F for frontal, P for parietal, O for occipital, T for temporal. These are the ways that you're going to remember the brain. As we go around and around, you can see that this fantastic little... oh, there goes my phone, but I won't answer that. You can see that there's our brain in two halves right in here, which they won't highlight, but that is the corpus callosum. There it is in the middle. Check out that guy. Alright, you know all about that as the brain swivels around. There we go, keeping our brain together. So that's what you're going to learn about today, the brain and all its parts. And we are going to start at the front. There it is. Alright. So here is our frontal lobe. Look at it, isn't it fancy? So you can see here, oops, wrong way. It's at the front of the brain, over both hemispheres, okay? This is what we call a prefrontal cortex. You don't have to worry about that. This here, the green and the yellow, the primary and premotor cortex, you just need to think of those as the motor cortex. Okay, so when you're looking at that, it's the motor cortex. So that's kind of important. Oh, we want the brain to go that way, and then we want the brain to go that way. All right, because you're going to need to know, you can see there is a bit of a, if I just draw a little line through here, that's kind of where the brain splits in half, pretty much. Front and the back. Go away, you. One easy way to remember it is that basically everything back this way from that line is sensory. So that's input. Right? My writing's really bad, but that's okay. Everything on this side of the line, all this stuff, that's output. So that's everything that goes out, everything you can see moving in and out. Everything that comes in, like your senses and your hearing and your touch, and all of those things, they happen in this area here. Okay? So, something to note. Alright, the frontal lobe and what it does. You can see here, this is what's great about this website, is that you've got a fantastic little startup pack of what the brain is, the frontal lobe is really about. It gives you a nice little overview. As you go down, it can give you some case studies, so it gives you a more in-depth look at something in particular. But they're talking about a lobotomy, which is where if people had some severe, well, if they were severely criminal or they had a drinking problem or something like that, what they used to do is that they used to chop out parts of the brain, thinking that that would make all those problems go away. It did sometimes, but it made other problems occur. Now, you have these areas here, which are interesting to note. Associated functions. So, what's the frontal lobe all about? Well, it says here, planning, problem solving, voluntary motor control, okay? Remember that comes from the motor cortex. So any voluntary movement. You know, if you're going to dance the YMCA at the next wedding, this is the part of your brain that's going to be working the hardest, okay? Also, some language stuff which comes from Broca's area, which we're going to learn about, and also things like language comprehension, okay? So, premotor cortex, or the motor cortex as you know it, is really important for your voluntary movement. Okay? Your ability to dance, your ability to move your fingers, play the piano, look up, look down, all those kinds of anything that you want to move to get something, okay, then this is the part of the brain that's involved in that. Prefrontal cortex, this area here is where we do a lot of our problem solving, as was said before, okay. If you damage this area, okay, especially the motor cortex, it's involved with voluntary movement. If it gets broken, what can't you do that much anymore? Move, okay. Now, sometimes people with strokes, you see them, they can't talk properly for various reasons, or they can't move one side of their body. That is due to damage, usually to the motor cortex, okay. Also says here, mood changes, inability to express language, okay, and social skills stuff. How do we know this? Well, research, of course, but sometimes we can't just chop people's brains out, because that's not cool, they don't like it. We use case studies. One of the most famous studies for damage to the frontal lobe was a man in the 1800s called Phineas Gage. Funny name, but you'll remember it if you Google it. And here's a photo of our fantastic Phineas. Handsome fellow, isn't he? He's looking very nice there in his jacket, holding this thing here, a giant metal rod, I suppose. Phineas used to work on the railways, and he was in charge of blowing up large sections of area so that they could move away the rubble and make a nice little track, I suppose. Anyway, he used to use this thing here to put the dynamite, pack the dynamite into the holes before it blew up. One day, unfortunately, it blew up, and it went into his eye and out the top of his head, kind of through on that kind of trajectory. You'll see it in a minute a lot better. That's why he's not winking at you. He doesn't have an eye there anymore. He managed to survive. I'll show you very quickly. This has been remade years later. This was only done a couple of years ago. This is the trajectory of the iron bar, metal bar, as it went through his head, just under his cheekbone there, behind his eye, and out through the top of his head. You can see the frontal lobe there. So quite extensive damage, really. Once they took that out, there would have been quite a gaping hole, which wouldn't have been very pretty at all. But that was Phineas Gage. So what happened to him? Well, he was studied by lots of doctors at the time to find out how he survived and all those kinds of things. Basically, what you need to know is this. Phineas Gage ended up having, he could do most of his jobs pretty well, but what he ended up having was mood changes, okay? He was generally a nice kind of guy, by all reports, relatively quiet, became aggressive, swore a lot, was short-tempered, not a very nice guy to be around. Also, you know, he lost some of his social skills, okay, and his personality traits changed. Became a bit of a drinker, and basically was not as nice to be around as he was prior to that. And I think he struggled to integrate back into society. Still kind of held a job for a while, but not very successful. So that's Phineas Gage. Interesting character. You can read about him in your book. There is a little story about Phineas Gage on page 186. You can read all about Phineas Gage in your textbook. All right, now we're going to go into another exciting part of the brain. It's called Broca's area. It is in the left hemisphere only, as this fantastic website tells us. And what does it do? Well, me being able to talk to you is working my Broca's area hard. All right? It's to do with speech production, right? So what it means is that I can articulate the words that I want to say. I can maneuver my lips and my tongue and all those kinds of things to be able to say the words that I need to say. I can also attach, my brain attaches meaning to them in this part, and it also does a clever little job of being able to understand some of the really important grammatical structures of a sentence, how it all fits into place, so that I can say, the cat sat on the mat, rather than Matt sat cat had on. Does that make sense? Hope it does. So it's to do with speech production, your jaws, your muscles, all those kinds of things, and the appropriate words and when to use them. Okay, so that's Broca's area. Now, if you get damage to that area, it can cause you something we call Broca's aphasia. I'm going to write that down. I'm going to get rid of that. And we have Broca's aphasia. So if something goes wrong, we have something called aphasia. I might see if I can put that in the title on the video, but we'll see how we go. So, what does Broca's aphasia do? Well, interestingly enough, it struggles with your speech production. Okay, so Broca's aphasia, what does it do? Well, if I had Broca's aphasia, I couldn't do what I'm doing right now. Okay, we know that Broca's area is associated with being able to produce speech. So, if you have damage to that area, you cannot produce speech, which means that you struggle with the smaller joining words, things like and, if, but, all those kinds of things. So, on the podcast, Dr. Brian talks about, saying if I wanted to say the sentence, I drove out to the country today because it was a nice day. If I had Broca's aphasia, I might say something like, drove car, country, day, nice. Wouldn't really make sense. So I couldn't put all the little parts of that sentence together to give it meaning. Okay, so my production sometimes would struggle, so I maybe even couldn't pronounce some of those words. So I might say things like, instead of saying McDonald's, I might say McDonald's or Donald's, something weird, who knows. But I might struggle to say those words, but also I would struggle to put them in a nice fluent sentence. Okay, so that's Broca's aphasia. Aphasia means damage or not working really well. Okay, so that's that. Okay, the next bit is the parietal lobe. Check it out. It's pretty crazy, isn't it? All right, this awesome little pink bit here is the somatosensory cortex. This is the sensing agent of the brain. This is where most of the sensory information from your body, fingers, mouth, toes, all that kind of stuff, comes through this section of the brain, okay, before it goes off to the other parts. This is the sensing part right next to the main motor cortex. So they're very close together, these parts of the brain. If we go, whoops, what happened there? If we go up, oh, do a big skip, you can see here, remember this is the somatosensory cortex. This is where the motor cortex runs. So the top part, the middle part of your brain across here is very, very important. So you don't want anything to fall on that, otherwise you won't be able to sense things or move things. But let's get back to the view that we're familiar with. Alright, here we go. So the parietal lobe, again, tells us here what we're talking about, so I don't need to go into too much detail here. What you do need to know is that parts of vision come through this area. Okay. You also need to know that it's very important for your brain. This part of your brain deals with where you are in space. Okay, so it's good for reading maps. It's good for judging distances of things, and it's also good for how you move and interact with the world, as it says there. Okay, so that's really important. What you also notice here is that they talk about hemispatial neglect, okay, or just spatial neglect, and we're going to learn about that in a very short amount of time. But what else is this part of the brain associated with? Well, it's the senses, okay? It is all the incoming information. So it's being able to touch, temperature. Also, it deals with your spatial attention, what you're paying attention to, and other things like that. It also says here, it talks about number representation. Okay? So, spatial neglect, what does that mean? Well, I'll show you an example of someone who has or had spatial neglect. This is a drawing test. I would definitely fail it because you all know how bad I am at drawing. But what do you notice? You'll notice that the person who has drawn the pictures has neglected all the areas on the left-hand side. Now, this is not because they don't see them, because they can see them. There's no damage to their occipital lobe, but there is damage to the part of the brain that pays attention to the left-hand side. Okay? The information that's coming from the left field is not being attended to. So you generally, what does that mean? The right side of the brain. So it means that what's happening is that you see it, you just don't pay attention to it. Okay? So I'm sure right now there's information coming from behind you, but you're not paying attention to it unless you turn around. It's my fridge. Anyway, my point is that this spatial neglect deals with neglect usually of the left side of the visual field. So you can see here that they have neglected the left-hand side of the clock. They were asked to draw these three objects. They've done a pretty good job here, but they have neglected the left-hand side. All right? It's important with spatial neglect that we remember, okay, all right, with spatial neglect, that what they are doing is, it's not that they can't see, but that they can't pay attention to that side of the visual field. Okay, so that's really important. All right, that's basically all from the parietal lobe. We're going to learn about that a little bit later too. So, interesting little part. That's the F, the P. Now we go back to the occipital lobe. Let's go to the occipital lobe. Okay, now it's going to disappear, but you can see here the occipital lobe, right? Important part to do with vision. That's basically it. Interestingly enough, that the part that deals with our eyes is at the back of our head, but hey, isn't the world and the mind and the body a wonderful thing? So, here we go. What do we need to know about that? Well, your last year's study design would have got you to find out about synesthesia. Not that important, really. In this, it's not in your study design anymore. It's a great, cool disease to find out about. It's when you can actually see music, or you can taste a word. It's really, really bizarre, but it's awesome. And they have their own music festival now. It's really, really cool. So check that out. So that's synesthesia. The occipital lobe. What happens when things go wrong? Hallucinations, blindness, of course. If there's damage there, you might not be able to process the incoming information. You might lose colour. You might lose the ability to see motion. I've talked in class a couple of times about the lady who saw the world as if she was seeing it via a strobe light. So rather than seeing a nice passage of movement, she would see it moving in chunks. And of course, synesthesia. But the occipital lobe, it's the eyes. There's not too much else to go into about that. Now we come to the temporal lobe. Okay, here we are. The temporal lobe. This lobe is full of cool stuff. Well, does cool things anyway. So, the temporal lobe. As I said before, this is kind of a university website, so you don't need to know all these cool bits in here, which have their own little, cool things. What you do need to know is auditory cortex, very important, and also super important is Wernicke's area. Okay? If you have a look over here in the temporal lobe overview, it talks about the substructures, which are all these different little parts of Plato over here. And it's important for a whole bunch of things. Okay? As I said, just before I go on, it's important that we understand that the temporal lobe has a strong association with memory. Okay, that's really, really important. Before we go on, I just want to tell you that the temporal lobe has a strong association with memory. Anyway, so The reason why I did that is because I want you to remember that. It's important because it is super duper connected with the other parts of the brain. Okay? If you look over here, what is it responsible for? Well, face recognition, object recognition, memory acquisition, all these kinds of things. Emotional reactions, sound, words, all of these kinds of things. If you damage this part of your brain, it can cause some real problems. I was going to say headaches then, but that was a bit cliched. But it's to do with recognition, it's to do with the perception of hearing, vision and smell, okay? And also understanding language and learning and memory. So the temporal lobe is a super duper important part of our brains for us, okay? As we have a quick look through some of the parts that are important for us, we have, as I said before, primary auditory cortex has a few roles. The primary auditory cortex, you're hearing the pitch of my voice. You're hearing the loudness of my voice. And all of those sounds get put together to be given meaning. Now, all that stuff happens here. Okay? Consider this. This is like the tape recorder. Okay, this has to take the sounds and figure out how loud they are, how soft they are, how high they are, all of those kinds of things, and transform them. But here is where it's all understood. Okay, Wernicke. Wernicke was he was a fancy little psychologist back in the day. I don't know specifically what day, but very important guy. 1874, so your textbook says on page 193. But nonetheless, very, very important. He found this part of the area and discovered that it was important for when we speak. It was very important for when we listen, okay, and very, very important for us to be able to get meaning from words, okay. As before, remember when we had Broca and we had damage to Broca's area was called Broca's aphasia. Same thing here for Wernicke's. Wernicke's aphasia deals with damage to his area or damage to this area of the temporal lobe, which causes a struggle with fluency. So remember with Broca's area, if someone had Broca's aphasia, they couldn't produce the words because it was more motor. Frontal lobe, motor. So they couldn't produce all the words. With Broca's aphasia, they can produce words fine, but they've lost the ability to give them all proper meaning. So they will speak normally, but it won't make any sense because the words don't have any meanings. For example, they might say something like, I went down the street, elephant, giant car, and grass bricks went up my nose to the salad dressing. Sure. All of those words are words. All of those words had the right kind of intonation, but they didn't make any sense. This is because Wernicke's area is associated with memory, it's associated with giving words meaning, and then you put those together and it works in conjunction with Broca's area, then you can produce a nice sentence like that one I just said. If you have damage to Wernicke's area, you cannot give those words meaning. One really interesting thing about Wernicke's area is that if you have damage to the left side, which is where Wernicke's area lives, you might not be able to speak a proper sentence. But if you employ the right brain, so if you start to sing the sentence, then some people have been found to be able to sing the sentence they want to say, and it makes sense, but they can't speak the sentence. Because by employing the right brain, it takes some of the pressure off Wernicke's area. So that's just a cool little fact. Some other important things about the temporal lobe are, if you have damage to this area, you may also struggle with memory, You may struggle with being able to remember certain things about people. You'll notice if we go up here, oops, I'm in the wrong patch. You'll notice if we go up here, it says that it's associated with perception of hearing, of course, but it says vision. Now, why is that? Well, that's because there are two major paths in the from the occipital lobe. Okay, you have one path that once information comes into the occipital lobe, it then goes to the temporal lobe. Now, once it's in the temporal lobe, any visual information needs memory, of course, to figure it out, and that deals with the what? Okay, so because your brain in the temporal lobe is dealing with memory, but also strongly associated with the occipital lobe, when information comes in, okay, through your eyes, sometimes you need to know what it is. For that to happen, the information needs to go to the temporal lobe as well. Okay. You also, while we're on the matter of fact, if you need to know the where, so if you're looking at something and your brain needs to know the where, okay, it then goes up to the part of your brain that deals with space, and you in space, which is of course, as you know, the parietal lobe, okay, and that deals with the where. Okay, so and they're called the dorsal and the ventral. I don't know if you'll need to know that, but I'll write them here anyway. So dorsal and over here, this pathway is known as the ventral. Oh. My writing's pretty horrible, but that's okay. So the dorsal and the ventral, all right? These are the ways that, the reason I'm showing you this is because the temporal lobe is associated with vision in a small way. It gives it the what. And it, as I said before, it's really highly associated with memory and language. Okay? So that is the brain in a nutshell. So just so you remember, we'll go back. Frontal, parietal, occipital, temporal, F-pot. You know this. Frontal, movement, okay? Primary motor cortex. Then you've all got the parietal, senses, sensing information, touch, and all those kinds of things, right, with the primary somatosensory cortex. Occipital lobe, eyes, all you need to know, really, basically. Temporal lobe, memory, and a bit of vision, but hearing and language. And then you have the specialty areas, of course, of, I'll put them in here rather than go. You have the specialty areas of Broca's in here and Wernicke's, okay, and they are only on the left side of your brain, okay. So that's the brain in a nutshell. I'm going to start another video soon that deals with the other parts of the brain, the inside parts, the reticular activating system, so stay tuned for that, and the peripheral nervous system. But apart from that, see you soon. Bye.